Hello, and thank you for joining me today as we talk about acids and bases and the pH of acids and bases. So at the end of this video, you will be able to calculate both pH and pOH of a substance given at an initial concentration. You'll also be able to calculate concentrations given either the pH or the pOH of a substance as well. So for starters, if we're looking at different types of substances, whether it's neutral, acidic, or basic. So neutral substances, you have equal hydronium concentrations and hydroxide concentrations, or hydrogen and hydroxide kind of can be used interchangeably here. If you're acidic, your hydronium or hydrogen concentration is greater than your hydroxide. If you're basic, it's the opposite. Your hydronium or hydrogen is less than your hydroxide concentrations. Your pH levels at 25 degrees Celsius, which is kind of the standard temperature we use, is 7 for a neutral substance. It's got to be less than 7 for acidic and greater than 7 for a basic. If we're talking concentrations, your concentration of hydronium at 25 degrees Celsius is going to be equal to 1.0 times 10 to the minus 7th molar, because this is going to be the same for both hydronium and hydroxide. If you have more hydroniums than hydroxides, this concentration's got to be greater than 1.0 times 10 to the minus 7th molar. So the power's number's got to be bigger than 1, or the power's got to be less than. So it's got to be a -6, a -5 to be a bigger number. And likewise for a base, hydronium is going to be less than this 1.0 times 10 to the minus 7. So if we look at calculations here, what is the pH of a solution if the hydronium concentration is 3.4 times 10 to the minus 5th molar? Remember pH. P stands for negative log, so pH equals the negative log of your hydronium or hydrogen concentration. So to calculate this, we're going to take pH of this question is going to be the negative log of 3.4 times 10 to the minus 5, and molar can be in there, but it's not going to a calculator. So if you take the negative log of, make sure you use parentheses on this number behind log. So take the negative log of 3.4 times 10 to the minus 5, should get a pH value of 4.47. So pH in this question, this example should be 4.47. And you will notice that if this were 1 times 10 to the minus 5, your pH would have been 5. 1 times 10 to the minus 4, your pH would have been 4. This number is somewhere in between those two. There's more than 1 times 10 to the minus 5 because 3.4 is bigger, but it's not quite times 10 to the minus 4. So this number makes sense because it falls in between 4 and 5. Another example. I want to know what is the pH of a 1.0 times 10 to the minus 3rd molar sodium hydroxide solution. So here we have to be careful. On the last one, I told you the hydronium concentration. On this one, I told you the concentration of sodium hydroxide. So I know that if I have sodium hydroxide and I put it in water, I'm going to get Na plus OH. And because these are 1 to 1 to 1 ratios, I have a 1.0 times 10 to the minus 3rd molar, which means sodium is going to be 1.0 times 10 to the minus 3rd molar, and hydroxide is going to be 1.0 times 10 to the minus 3rd molar. I want the pH, however, and so I only have a hydroxide concentration. So in this case, I need to use my hydrogen or hydronium times my hydroxide equals Kw. And remember, Kw is 1.0 times 10 to the minus 14. So I know that my hydroxide, or my hydrogen times 1.0 times 10 to the minus 3rd has to equal 1.0 times 10 to the minus 14th. So I can divide this 1.0 times 10 to the minus third across. And this will give me my hydrogen concentration. So again, because we're dividing here, 1 divided by 1 is going to equal 1. And because I'm dividing, I can subtract these. So negative 14 minus negative 3, this should end up being 1.0 times 10 to the minus 11th molar. And that's my hydrogen concentration. So to get pH, I'm going to take the negative log of 1.0 times 10 to the minus 11. And if I do this, I should come out to a pH of 11. Because this is a 1 and this is my negative 11, so that's going to go to the front. So this pH should be 11. You'll notice this is a basic solution, pH of greater than 7, and we're talking sodium hydroxide, which is a base. It's got OH on the end, that's a base. So my pH is going to be 11. The second question, what is the pOH? Now we can do this in one of two ways. Let's do it the way we know how. So I gave you a hydroxide concentration of 1.0 times 10 to the minus third. So let's take the negative pOH equals the negative log of 1 times 10, I'm just going to use e to the minus third. So negative log of 1 times 10 to the minus third is going to give me, just like this gave me 11, this one's going to give me 3. So my pOH equals 3. Okay, now there's a shortcut for this. So we've talked that we know that hydrogen concentration times hydroxide concentration equals my Kw, which is 1.0 times 10 to the minus 14th. Okay, we know that to find the pH, we take the negative log of my hydrogen. We need to find pOH, take the negative log of hydroxide. We can also find the P of Kw, which is the negative log of Kw. So if you take these numbers, you'll notice pOH is 3, pH is 11. So one thing we can do, a shortcut, is you should write this down, is pH plus pOH is always going to equal 14. So if you solve for one of these, either pH or pOH, you can work backwards by taking 14 minus that answer. Here's an opportunity for you to practice, find the pH of different substances. You can find the pOH as well while you're at it. I've only given answers, I believe, for pH on the next slide, but pause this if you want to do that, and then you can check yourself right here. So these are pH answers for those questions. If you came up to a different solution, please talk to me. I could have made a mistake as well. So talk to me and we'll figure it out. Now, we've gone from concentration to pH, and we know that pH equals the negative log of the concentration. If we want to work backwards, if we want to find concentration values, if we're given a pH, we have to go and use the opposite function as that of log. So we use the negative log to get concentration, so we have to use the anti-log to get to your concentration values from pH. So if we would take pH and divide by the negative, we get a negative pH, and we take the anti-log of that. So your concentration of hydrogen is equal to the anti-log of the negative pH. And you will notice when you hit the shift log function on your calculator, it's going to give you this 10 to the x. So anti-log is taking 10 to a power. And that's all that is. So you have to take 10 to the, and it's got to be a negative pH. So make sure your power is going to be negative here. So I want to know what is the, if the pH is 3, what would my hydrogen concentration be? And so we know that concentration of hydrogen is going to be equal to the negative log or anti-log, which is going to be 10 raised to the power of negative 3. So that is going to be my hydrogen concentration. So 1.0 times 10 to the minus third molar is going to be your answer here. So this one works backwards. In terms of when it's a whole number, very simple. When it gets to 3.5, it's harder to do in your head. For example, determine the hydronium concentration, hydronium ion concentration of an aqueous solution has a pH of 4. So again, we know pH equals the negative log of this hydronium or hydrogen concentration. If we're working backwards, we have to take we have to use the anti-log. So this is going to be my 10 raised to the negative pH, which is in this case is 4.0. And so voila, there's your answer on this one as well. 1.0 times 10 to the minus 4. And it's got to be molar because we're looking at concentration numbers. Okay? On this example, the pH of a solution is measured and determined to be 7.52. I want to know the hydronium concentration, the hydroxide concentration, and if the solution is acidic or basic. Because I've given you a pH right now, we can answer question 3. And because this is bigger than 7, this solution is going to be basic. Now let's work backwards. Let's get the hydronium concentration. So I know that my hydronium is equal to the anti-log, or 10, raised to the negative 7.52. So if you plug into your calculators, you hit negative log or shift log, should be a 10 raised to the power. Make sure you use a negative 7.52. And you should get an answer of 3.02 times 10 to the minus 8. That would be my hydronium concentration. Okay, now that we know this, we can use our hydronium times hydroxide equals Kw and solve for hydroxide. So I can take 1.0 times 10 to the minus 14th divided by 3.02 times 10 to the minus 8. And be careful on this. Make sure you use parentheses around this number to get your answer. And you should come out to 3.31 times 10 to the minus 7th. Should be your hydrogen concentration, or hydroxide concentration. My hydroxide concentration should be there. My hydronium concentration is here. Okay? Those are hydronium and hydroxide concentrations. Here's a chance for you to practice. So in the first one, determine what the hydronium ion concentration is. Second one, I want hydronium concentration as well. This last one, or the third one, I want both hydronium and hydroxide. And on the last one, I just want hydronium again. So pause this, work through those, and then here are your answers. So there's your answers to check. You'll notice if you multiply both these two together, you should get 1.0 times 10 to the minus 14th for your Kw. And this is one last question for you to try. I want you to determine the hydrogen concentration, hydroxide concentration, pH, and pOH of a 6.25 times 10 to the minus 3rd molar calcium hydroxide solution. If you have questions on this, please see me and we'll get them straightened out. But thank you for your time and attention, and enjoy the rest of your day.